folks, I want to take a look at number 7 and just give you a heads up. This is a doozy. So we can get into the weeds on some of this, but I want to go ahead and get a graphic solution. I want to find the feasible region for the system of inequalities. And then I'm going to get into the weeds on how you actually find the intersection point. So if I were to switch this over to equal signs, right, this would be x squared plus y squared equaling 25. And this would be 3x squared minus y squared equaling 12. And depending on your familiarity with conics, you might recognize that this one here is a circle. And apparently I can't spell the word circle today. This is a circle, and this one here, this equation is a hyperbola. And if you're wondering like what I'm talking about, it's a concept in math that we talk about called conic sections. All right, so my guess is you've heard of circles before, maybe hyperbolas, maybe an ellipse, maybe a parabola, well, definitely a parabola. We've done parabolas in here. But conic sections are a topic in math. I believe they're in chapter 8 of this book. We don't cover them in this course, but they're out there. And I'm hoping you've had some previous experience with them. So for this circle, we would say the important factors of a circle, we usually look at the center, which is at 0, 0. And we look at the radius, which in this case is 5. It's always the square root of that number. So we can use that when we graph it, and I'll just separate that out here. Now hyperbola, when we go to put it in graphing form, we usually want a 1 on this side. So if I divide everything by 12, right, if I just simplify this a little bit, I'll have x squared over 4 minus y squared over 12 equaling 1. All right, now I will go into the weeds, and it is going to be weedy. It's going to be some really ugly numbers in a bit. I'll go into the weeds on how to find out where these officially intersect, like if I was going to solve this system of equalities rather than inequalities. But before I get too far into the weeds, let me just graph these, and let's talk about finding a feasible region, okay? So let me start with my circle, all right? And this again will come back to how much experience and how familiar you are with your conic sections. Okay, so let's start to piece this apart. So let me go 5 units in either direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the easy part. 1, 2, 3, 4, 5. All right. So now I'm going to make a dotted line because that inequality is strict. I don't want to include the solid line of x squared plus 25 is actually equal to 25. Oh, I think I said that wrong. X squared plus y squared equals 25. Okay. There's my dotted circle. I either want to shade inside the circle or outside the circle. So let's use a test point. And you know me, I like zeros, so I'm going to use 0, 0. So let's use a test point of 0, 0. All right, is it true that 0 squared plus 0 squared is less than 25? If it's true, I'm going to shade over 0, 0. If it's false, I'm going to shade out of 0, 0. But 0 is less than 25, so I want to shade here. All right, let me blur it a little, mush it. Kind of like the last problem. I'm not sure how much actually shows on camera. All right, but I have inside the circle, okay? Now I'm going to make a hyperbola. And again, really depends on how much experience you have with hyperbolas. But when the x term is positive, that means we're going to have a left-right hyperbola. So when it comes to hyperbolas, let me just put a little thing here. When you have hyperbolas, right, it's kind of, even though it's not really, it looks like 2 parabolas put together. So you either have this kind of hyperbola, a vertical hyperbola, or you have, if this is x and y again, that's supposed to be a y. You either have, or you have a sideways hyperbola, okay? So vertical hyperbola, horizontal hyperbola. But because the x has got the positive term, I've got a horizontal hyperbola. And how you kind of parse this out is whatever number is in your denominator, so long as this is set to 1, these are going to be where your vertices are, right? So we're centered at 0, 0, but because this is 4, I'm gonna go out the square root of 4 units horizontally from the center. So go with me. My center is 0, 0. Square root of 4 is 2, so I'm going to go 2 units this way. That's going to be a vertex. 2 units that way. That's going to be a vertex. And my hyperbola is going to look like this. Ooh, and I just realized I messed that up because this should be dotted. So let me erase this and do it again. And as I'm sitting here kind of fixing my typo, if this had said y squared over 4, if that was the positive term and it was minus x squared over 12, then I would go up and down too. All right, so let me go ahead and do this. All right, so just to get my feasible region, ultimately I'm either gonna shade here on the hyperbola or in the middle. And I'm gonna test out 0, 0 again. So now if we test out 0, 0 on that second inequality, right, on this one is 3 times 0 squared minus 0 squared greater than 12, right? I wanna test out 0, 0. All right, and I'm gonna put a little question mark over it because I don't know if it's true. All right, 0 squared is 0, 3 times 0 is 0, 0 minus 0 is 0. Is 0 greater than 12? No, that's inherently false. So I don't want to shade over the origin here, meaning I want to shade in here. So I want to shade kind of inside the hyperbola, if you will. But where did those two shadings overlap? You can kind of see them on the footballs on each side. So these two regions collectively is my endgame answer. That is my feasible region. And I'm going to take a moment and show you how you get this ordered pair, this ordered pair, this ordered pair, this ordered pair, but it's going to hurt. So that's why I just wanted to kind of give an overview of how you get the answer. This is the answer. But if I want to figure out what these ordered pairs are, whoo, buckle up, right? Things are about to get real. So I need to give myself as much space as humanly possible because this is going to take a minute. Well, it's not going to take a minute, it's going to take quite a few. So I'm going to rework this. If I have x squared plus y squared equaling 25 and 3x squared minus y squared equaling 12, I could add these equations together and eliminate the y squareds, right? And you might be thinking, well, that's not bad, right? 4x squared is going to equal 37 until you see the 37 here. And since that's not a nice number to take the square root of, I'm going to have all sorts of radicals in play. So when I divide 4 over, I'm going to get x squared equaling 37 over 4, right? And then if I take the square root of both sides, I'm going to get x equaling plus or minus the square root of 37 over 4. All right, well, if I want to distribute that radical, I'll have x squared equaling plus or minus the square root of 37 over the square root of 4. But we know the square root of 4, it's 2. So as I work this, right, I've got these two x coordinates. I've got square root of 37 over 2, and I've got negative square root of 37 over 2. And it's going to wind up being, this is going to be the x coordinate, that's square root of 37 over 2, square root of 37 over 2. Negative square root of 37 over 2, negative square root of 37 over 2, right? The x coordinates. I'm going to move 37, square root 37 over 2 units this way to the right, and square root of 37 over 2 units this way to the left. Those are going to be my x coordinates. And I'm going to pull 2 y coordinates, right? And that's going to get me my total of 4 intersection points. All right, but let's try each of these. I'm going to scooch this up because, like I said, this is a very, very intense problem. So we're going to scooch that up. And then here we go. All right, so let's try the case of x being the positive square root of 37 over 2. And then let's see what y value we might get. Or really, it's going to be y values. So as I start to burn through this, right, we know y is equal, or I should say, and I'll point up here, if 3x squared minus y squared is 12, I can move the y squared over and the 12 over. And we know, and let me write it, I'll write it here so you see what I'm referencing. I know y squared is going to be 3x squared minus 12. All right, so I'm going to go ahead and run this. So y squared is going to be 3 times, well, if I take the square root of 37 over 2 and I square it, we're going to get 37 fourths minus 12. Right? When you clean this up on your calculator, you're going to get 63 over 4. Okay. Well, that makes y the positive or negative square root of 63 over 4. Well, we know the 4 can come out, right? We've got plus or minus. I'm going to have a 2 in the denominator, but even inside of 63 is the perfect square of 9. So this is going to be 3 root 7 over 2, right? So what that's ultimately telling me is when x is the square root of 37 over 2, y is equal 3, either positive 3 root 7 over 2 or negative 3 root 7 over 2. So this ordered pair here, right? I told you we're going to get into the weeds. This is going to be the square root of 37 over 2 and then 3 root 7 over 2. Right? This one down here is going to be the square root of 37 over 2 and then negative 3 root 7 over 2. Right? And you can almost imagine what's about to happen here. I'm going to have negative square root 37 over 2 and then positive 3 root 7 over 2. Right? And here I'm going to have negative 3 root 7 over 2 and then negative, oops, sorry, I just realized I did that wrong. Let me fix this, right? This should be negative square root 37 over 2 and then negative again 3 root 7 over 2. You could also crunch these numbers on your calculator in terms of figuring out what root 37 over 2 is. All right, so if I pull my calculator into this, just because I don't want to deal with this, I'm not going to graph it. What I'm trying to say is I could take the square root of 37 and divide by 2. So that would just help me. And I could also do 3 root 7 divided by 2. So that's ultimately going to tell me my 4 points are 3.041 and then 969, right? And then I'm going to have negative 3.041, negative 3.969, and then I'm going to have 3.041, negative 3.969, and both negative 3.041, good Lord, negative 3.969. Right, so like I said, we can get into the weeds on this, but ultimately the end game is these two areas cumulatively, right? Here and here, these are our feasible regions. All right, thanks so much, everyone. Bye.